10 methods pathways, we can look at exercise 1.3 question 11. So we've got a scenario where the distance traveled with respect to time is drawn on a graph for a type of vehicle. Okay, so consider the graphs shown on the right. Write the value of the intercept and the vertical with the vertical axis. So the axis intercept happens to be 100. Kilometers. Okay. Find the gradient of this graph. Now, to get the gradient of the graph, you want rise and run. Okay. So if you look at the graph, what's my rise? What's my run? My rise is 480 because from 100 to 580, that's 480, and my run is 6. So my gradient m is 480 divided by 6, and it's positive, so we just leave it as positive. So 6 8s are 48, so it's 80 kilometers per hour. Remember, the gradient's always a rate. Okay, so the gradient is 80 kilometers per hour, and write an equation linking distance in Melbourne kilometers and the time taken. Okay, so y equals mx plus b. So what's asking you, instead of y equals mx plus b, we're substituting what the context is talking about. So the y is now d and the x is now t, because we're talking about time. So it's distance versus time. So I know that the gradient is 80 t, and the intercept, my b value, that's my b, sorry, my b value happens to be the intercept, which is 100. So that's my equation with respect to speed versus time. So what was the constant speed throughout the journey? Okay, so we can see the gradient, the slope is the speed. Okay, and we know the speed is 80 kilometers per hour. Okay, now you might be wondering, how do I calculate, what's the alternative way to calculate the gradient if I didn't know rise or run? You can just choose 2 points. So I'll choose this point and this point. So my first point is the actual axis intercept, so 0, 100 is the coordinate, and then this point would be 6, 580. Then you use the formula y2 minus y1 on x2 minus x1. So y2 is 580 minus 100, y1 is 100, and then you go x1, x2. x2 is 6 minus 0. So you essentially get the same answer, slightly longer way, but you still get the same answer of 80. Okay? So that's an alternative way of calculating gradient, and you need to be able to interpret what the gradient actually means. So in this case, it's a rate, it's speed, it's kilometers traveled per hour.